Okay, two things. One thing, it took a bit longer than expected, the first part, so I'm kind of going to try to make mine a little bit shorter in consideration with the audience. Second one is I'm going to do this in English on the spot, because I assume some people speak only English here. So let's start. So first of all, this is going to be a conversation about intro to data analytics. Who here has some experience with the GCP data pipeline and some of the products? Cool, so you might know all of the tools that I'm going to talk about. My name is Jonathan Yarkoni. I'm a customer engineer at the Google Cloud here based in Tel Aviv, Israel. My background is of development, and I was working on a large-scale application which was very much data-driven and relied heavily on analytics, so I'm very familiar with the whole side of reporting, ingestion, collecting, and then maybe most important of all is actually getting insights, which means querying your data and then improving your application. So this is the agenda and what we're going to talk. Just to go over the use case. So the use cases vary and they're quite incumbent on us today in the market. We have a lot of devices. We have computers, we have mobile devices, we have wearables, we have IoT devices, and they're all reporting a lot of data. If you just think of one game session on your Angry Birds and how many different touch points are logged and then reported to the cloud. If you think of IoT devices, and just one IoT device, which is one of 1,000, could have 1 million different sensors, which are all every couple of milliseconds reporting different data. You can very fast aggregate large amounts of data sets. It is in every industry. The more obvious ones are probably the IT industries, which are high tech, gaming, but we also see it happening today in the retail industry, where we have many clients who are interested in not only using one data set, but they want to take their offline metrics, combine them with their online metrics. And an example for that could be we have clients who would like to use their various touch points in their e-commerce website and their campaign metrics combined with their offline purchase. Because if we're trying to measure conversion and the last step is offline, then we want to somehow log the data, bring it together, and merge it into one data set through which we can actually measure real insights. So, why Google? First of all, we're committed to innovation, and we have a proven track record. Now, what does it mean that we have a proven track record? You can go back and you can see that a lot of our various different products are a result of some paper that we've written a number of years before. We invest heavily in research so that you don't have to go and invest heavily in research, and you can focus on your core product. You can see some of the various researchers here on the screen, and these are some of the products that they later down the line mapped onto, some of which we will touch in this presentation. Now I'm just going to go over a common ingestion pipeline, which is a generic one. There's no one use case fits all, because when we're doing big data and when we're logging data from different places, so we want it to be durable, we want it to be redundant, we want one architecture to fit all. We don't want to work at small scale with certain architecture, and then when we suddenly expand and have a lot of customers have to switch to a different architecture. We want it to scale independent of a different design. And this one is just a generic pipeline so that you can see the different steps we take from getting the device's data until we can analyze and generate insights. So a common way to ingest and store is use Cloud Pub Sub or cloud storage. Normally we'll have a gateway situated right before these. It can be anything from our Continuum which is compute, to all the way to Google App Engine in the more managed services. From there, usually you want to run some kind of pre-processing on the data. Our managed ETL service is Dataflow. Some people who are more familiar and have done Spark and Hadoop can use our managed Spark and Hadoop, which is Dataproc. And the next stage, once we've kind of aggregated the data, we've done some kind of ETL process, either averaged or made it smaller so that we can more intelligently store it and query, and by intelligently I mean pay less. because with every architecture, we have to think. There's not one solution which fits all architecture. You have to take into account cost, you have to take into account limitations, and those kind of affect which tools you use and which architecture you design. Just if you're looking at cost, so the faster it is, normally the more it's going to cost you. The more managed it is, normally it's going to cost you more. The more redundancy you want in your data, it's going to cost you more. And these are trade-offs which we have to take into account. Once you have your data, and this is kind of the pinnacle and where Google shines the most, is machine learning. I'm not going to discuss machine learning in this lecture. I have a completely different lecture which discusses machine learning, but that's eventually where we'd like you to end up when we do a lot of things in order to make it easier. Whether it's differentiating between storage and compute, so that it would be efficient for you to do it, or some of our latest projects which are, if you've heard of AutoML, which we released 2 weeks ago, you can think of it as something along the lines of machine learning as a service, because you don't really have to write code, but you can still generate a complete machine learning model which answers your specific use case. Along those lines, and on those I will only discuss very briefly, normally at the end of the line, aside from garnering insights, you would want to some way externalize the data. It would either be showing it to colleagues. Most of the times we hear use cases where the developers know how to query the data, they know how to see the data, but they want to show it to the executives, and they probably would not log into the console and perform the query themselves. So here we have hundreds of different tools. We also offer a free tool which is called Data Studio, which we will see in the end, briefly. So the first step of the line is ingestion. And we discussed Cloud PubSub. So Cloud PubSub is our messaging service. You might have heard of similar things like RabbitMQ and Kafka. PubSub is a very rigid, simple implementation which works with a simple API and works at scale. It's globally, and I'll go over what that means in a second. There's a delivery of at least once delivery guarantee. And maybe the most two important things are it's scalable. Okay, you don't have to define anything. There's no configuration which goes into it. You simply use it. Every message can be up to 10 megabytes, and you can scale to millions and millions of messages. And we rely on it. It's based on our cloud. It's backed by our cloud. It scales automatically. And you might have heard of a company such as Spotify, which have been very public about their use in Cloud PubSub. And they are, I don't know how many millions of messages, but you can take their users and extrapolate the number of messages, and they also have a very interesting blog post of how they migrated from a managed Kafka to using our managed, their self-managed Kafka to our fully managed PubSub. And it's very highly performant. There's an SLA, and it works very fast, and all of these things combined together make it a very lucrative offering. So I said it's a very simple API, and what does simple API mean? First of all, that there's no configuration needed. You can just create a topic, you can subscribe as a subscriber, connect these two together, and you can add as many messages to one topic and as many subscribers as you like on the other end. It works in one-to-one, one-to-many, and many-to-many. Yeah.
What's the difference between this and Firebase?
Oh, so the Firebase is actually a suite of products which encapsulates a lot.
It's
a different
database.
Yeah, let's say
I'm using Firebase.
So let's say it this way.
Cloud messaging.
Let's say it this way. Like the real-time database is probably in the background. I'm not sure about the implementation.
Right.
It's based on PubSub in the background. Any other questions up until now? Great. So at least once delivery guarantee just means that there's this handshake, and until the handshake is performed and the user says, or sorry, the subscriber says that he has received the message, then we will try to resend the message. And global. We have a very, very powerful load balancer, and our PubSub sits behind this load balancer, and the benefits are it's globally accessible, and it has one endpoint, and you don't have to worry about putting the messages close to where your subscribers need to ingest them. We'll take care of that. And you don't have to configure the load balancer, you don't have to configure the front end or the back end or anything to work with it. It's globally available behind one IP. Good. Next, I just want to be aware of time here. Next is the cloud storage. Cloud storage is our blob storage. It works with a single API. It has a very seamless API across, the same API consistence across all of our different storage tiers. By the way, it's very similar to S3 in the matter of its API, and it's also very easy to transfer or sync all of your data from an S3. It has millisecond time access for every class, and I'll discuss the classes in a moment. And we have a very robust lifecycle management tool which you can apply. What does this robust lifecycle management tool mean? It means that you can save costs. I'll explain how in a moment. So our different tiers. We have 4 different tiers ranging from multi-regional, which is our highest availability, to regional, to nearline, to cold line. You can see that the things which change are the amount of times that you should access, the SLA. Obviously, when you're multi-regional, your redundancy is much higher, which allows us to commit to a higher SLA, and the pricing. What doesn't change is the time to first byte. Any of the tiers, you store them, any data in any of the tiers, the time to first byte is always the same. So you might ask, okay, so where's the catch? And there's not so much that there is a catch, but that we operate in a smart way. If you decide to store your data in, let's say, cold line, because you say, well, that's the least cost for me, that's where I'll put it, then if you'll end up querying it, and you can see this line which kind of represents the retrieval frequency, if you try to retrieve data more than what it was intended for, and you can think of cold line as once a year, nearline as once a month, regional as much as you'd like, it's just a matter of redundancy, and multi-regional much the same as regional, it's just, again, higher redundancy. If you access it more than the tier that it was intended for, then it will automatically bump that file to a higher tier. And you'll just, from that point on, end up paying more for it. Any questions thus far, before I move to the second part?
Only a small question about the storage. Storing small files contrary to large files. The recommended one usually, like using any blob storage, is like storing big files because you access a lot of times with HTTP requests, right? Mm-hmm. So what happens when you have a lot of small files? Do you run into any problems like running big data workloads, etc.? Like in S3, you have that problem of listing all the files in a bucket.
The short answer is no. The better answer, which I much prefer, is always test what you're doing. Mm-hmm. If you need a different solution or a different architecture, then adjust accordingly. But there shouldn't be a problem in access. Yeah.
My question is about how cloud storage implemented under the hood. Can you go to the previous slide?
Yeah, but I can't really go into how it's implemented over the hood. Okay.
So, is it just a question of pricing? So implementation is the same for all tiers?
So,
or each following tier just doing proxying for the previous tier, like cache read-through?
So no, it also affects us. I mean, through all of our different services, every time that we're able to save, then we try to incur the cost onto the user. That doesn't answer your question, but what does is that the reason most of the times that we are able to save is because it's easier to manage. So I would imagine, if I'm extrapolating onto this service, that code line operates in a way that's much easier for us to manage as long as you don't access it more than once a year.
There's also the number of copies. Storage.
Yeah, also the number of copies. It applies to multi-regional and regional only, right? Yeah, so again, redundancy you get with a certain redundancy with multi-regional and regional, obviously.
I can say something about it. It uses the same. Hi, I'm Sharon. I'm from working with Johnson. The nearline, code line, and regional are the same as far as data cluster. There is no difference. It's not like the code line is stored in tapes and.
So it's just pricing?
It is just pricing, and it differs according to your consumption. In Nearline, you will not pay more if you don't consume it, because it is intended for long-lived, aged-out data.
Great.
But,
Let's just continue because I have to be kind of time aware. So yeah, I agree and build upon which, everything that Sharon said. And I think that if you only take one key takeaway, is that no matter in which different tiers you store, the time to first byte is identical, which is very, very different if you compare it to other services, where storing it in a very cost-efficient way, let's say cold line, would actually incur very high amount of time to first byte. Great. Now, a bit about the processing, which is the second stage, what we've actually gotten the data from the devices and brought it to, let's say, our VPC environment. We would like to process it. Cloud Data Proc is our managed Hadoop Spark. It normally fits people who have already worked with such technologies on-premise, and we understand that it offers a lot of value to have a managed service. And what are the key takeaways about our managed service? So first of all, out of the box you get managed Hadoop Spark. We try to keep updated with the latest version. We publicize which version is available, and we even have a preview version if you're interested in the latest and greatest. Out of the box we offer Hadoop Spark Pig and Hive, but you can also do different things on it. You can install Data Lab, Presto, Kafka, just by using initialization functions. The nice thing about it is that we've kind of changed the way you work with it, where normally once on-premise you would have this very large cluster which everybody would use, and you would have to manage it and you would have to scale it. The more users you use it and the more workload you would have. Because we're able to spin up a cluster so fast, we actually change it from a cluster methodology to a job methodology. You don't have to work this way, but if you want, you can actually just spin up a cluster. It will take 90 seconds. It will do your job. And once it's done, you can schedule deletion. And you can schedule deletion to say something along that. There are various different rules, but you can say schedule deletion if the cluster has been idle for such and such time. And to add and remove workers, you don't have to shut down the cluster. מתי התחלתי, דוד? You know?
Yes, it was like an 55.
Oh, so I'm going really fast. Okay.
It's okay.
Never mind, I'll continue. So a bit of a look under the hood. So we, maybe opposed to different other services, we've taken the approach of making it easy to migrate, and making it not only easy to migrate using third-party services, we also make it easy to use. So you have an API, and you can use the command line, you can use the REST API or the console, but you can also access directly and use the HBase API. We have the managed service is built based on Hadoop, but we've layered in a number of different things, from visibility to monitoring to access to various different services within the cloud. And the nice thing is that if you have some kind of low-level configuration within your cluster, it's not this hermetic box or something. You can actually drop one level down and do some self-configuration on your cluster, which again is all along the lines of, we want to offer a managed service which has built-in stack driver and visibility and monitoring and all of these things, but we still would like to have people have the same experience as much as possible with what they're used to working already at home. And this just shows kind of the two things which I wanted to touch upon. The first one is what I said with the job methodology. You could have one big cluster and divide it between different jobs and workloads. You can also define canary clusters, which have new versions, and once they become more stable, you can divert more traffic to that cluster. And in that way, you can have a more semi-long-lived cluster behind this load balancer. And on the other hand, you could have these short-lived clusters because we can spin them up so fast. You can work in a job-oriented environment. Both of all of this has the nifty nifty thing which, again, you don't have to, but it offers the separation of storage and compute, and it's HSpace compliant. So what does it mean? The fact that it's HSpace compliant means that you can use the same API. Also, like Demi mentioned before in the previous lecture, Google Cloud Storage, which is the second solution that we reviewed, is based, it's like an evolution of the HDFS, so it's also HDFS compliant, which means that you can save your data there and then run federated from your cluster, access the data. So on the one hand you have the compute, and on the other hand you have the storage. And you're paying efficiently for the storage, and you're only paying for the compute you use, and you don't have to kind of have these two things connected, having to increase your cluster just to get more storage on the other hand. Yeah?
I think on the data prop side, you can actually like incorporate working with preemptible VMs too, right?
Yeah, so okay, I'll just touch upon that point, if it was already mentioned. Preemptible machines are machines which you can get at a lower cost, up to 80% discount. The thing about preemptible machines is that at least once in every 24 hours we'll take them away, and you'll have a 30-second notice. For some workloads, like I said, you have to design for what you're trying to reach. For some, it works. In Dataproc, you can use preemptible machines. It has to be a ratio of 80%. You can go up to 80% preemptible machines, 20% non-preemptible machines. And if you don't specify anything, then by default we'll give you 2 non-preemptible machines. Obviously, because you have to have some kind of master. Now, you wouldn't want to have like a master taken away, because that would probably create a lot of problems. Cool. Any more questions up until now? Great. Next, we have Dataflow, which is our, you can think of it as our managed ETL service. It's based on Apache Beam, so we built Apache Beam, then we open sourced it, and now we've built a managed a managed service which runs this Apache Beam. Just to reiterate the second slide I had, I said that we're committed to innovation and we write a lot of papers. So, by the way, Dataflow is a combination of the MapReduce paper, the Flume Java paper, and the Millwheel paper. So it's not that every paper necessarily creates a product, and it's not that every paper necessarily creates one product. We took the concept of MapReduce and from one paper, and then we took the concept of batch from another paper and streaming, and we combined them into two. So you get this fully managed, no operations need data processing ETL tool, and you get stream and batch processing in one framework. What does it mean, stream and batch processing? Yeah, of course, and parallel processing I'll go over in a minute.
Per event.
Yeah.
The meaning not micro batches or like in Smart.
Yeah, we're gonna go. That's like next to the slide. What I mean by having the same framework apply or the same code apply for streaming and batching, that you actually write the same code and how you want to process it, and then you can just switch line of code to decide whether you're doing it as a batch workload or whether you're going to handle streaming. Now I want to touch a bit more about how the streaming is handled. It might be a bit too low level, but I think it's still very interesting to know. And from here, it might make your deep dive into Dataflow a bit easier. So when you're working in a streaming model, there are a few things you need to take into account. So what, where, when, and how. And we'll go over each of these separately, and I'll have some examples trying to demonstrate what I mean by each of these. First, when you're reporting analytics, and whoever here has had some experience, you know that there's normally an event time, and there's also a processing time. Ideally, you would want the event time and the processing time. The processing time is normally when it has reached your machine. Let's say you have a machine for the cloud, which is ingesting data. So the processing time is when the message has actually arrived. Ideally, you would like what's called the watermark to be also the dotted line. That's your ideal. Normally, events take time to reach the cloud, to reach your machine, and it seems something along the pink line, which what we do is It's called the watermark, and it's based upon heuristics. So we know around how much time it takes the event normally to take, and we try to kind of create this heuristic-based watermark in order to decide when to stop processing events which have arrived from a certain event time. So what is being computed is what you actually want to do. Do you want to sum? Do you want to average? Do you want to do some other computation based on one key, based on a couple of things? And that's fairly the easy part. Here you can see just a normal batch workload which has various different events which occurred. It doesn't really matter when they have arrived, because ultimately it's a batch workload and you'll see them all, and you can take them all into account. Just to decipher what it's doing, because it might be hard to see from the back of the room, it's just summing up. It's the line is counting, and the more events it sees, just sums up more events. Where in time, there are three options. When we move to stream workload, which is the more interesting part and offers much more capabilities, we can do three types. So first of all, we can take a fixed window, which is just saying, okay, I'm going to look at this period of time, and everything that I get in this period of time is going to be accumulated to this certain window. And you can do a sliding window, which will say something every hour, look at the last 24 hours. But then you have to kind of wait in order to get the whole picture. And the third one is you can do a session-based one. So a session-based one, you can think of, you try to understand what is a session for a user. If you think of kind of example of a game, then you would try to take one sitting as one session. So here you can see the simplest of them all, which is just taking a fixed window of 2 minutes and running them. And then you get the results per each 2 minutes. When? So when is going back to this first picture which I showed you, of the watermark. Ideally, everything would be sitting on this dotted line, which is event time equals processing time, and we'd have no problem. But in reality, it's different, and sometimes you might have a user which is offline, you might have a sensor which is unresponsive or has no mobile connection at the moment and can't really relay backwards to your VPC or computer. It can't upload the statistics. The default is at watermark, what I showed you, which is this kind of pink line. But we can do kind of interesting things beyond. So this is just an example of what we think is the watermark, and as you can see, we accumulate up to the watermark and don't take into account things which have arrived later. Even though the window from 12 to 12:02 eventually sees the 9, because it's beyond the watermark, then we haven't taken it into account. Now, the last stage, which is probably the most complex and will require you not only to code it and decide that that's where we're working, it's going to kind of require you to sometimes make modifications on where you're saving data, because you might have like 2 events reaching. You might say, I want to take into account this late 9. I'll take it into account if it's arrived up to 10 minutes late. I'll fire another update, but then you have to take into account that that you've had 2 events for, let's say, the 12 to 12:02. And this is just an example of it running. So all of the stuff, the 9 comes in late, you still take it into account, as in contrast to the previous example, which didn't, it stayed at 5. This one does 5 plus 9, and you actually get twice the trigger for this time event. These are the different ones that I've shown for going from batch, which is very easy. You just give it all the data, and you then run some kind of MapReduce, and it runs in parallel and gives you the results. Windowed, streaming, and streaming plus accumulation. It doesn't end there. There's a wider API, which I encourage you to go home and experiment with. This is kind of just everything you get from having a fully managed service. The workload can be bounded if you're doing batch. It can be unbounded if you're doing streaming, which means it will just run and you'll get constant events. And that's it. for this. Are there any, yeah?
The code example you showed are using older API. It's not the Beam API.
No, it's a Beam API.
Yeah.
Yeah. And Beam API you can write it in it's in Java and in Python if anybody's interested. Okay, next is Cloud Data Prep. Before I talk about Cloud Data Prep, I'll talk about the motivation behind the creation of Cloud Data Prep. We understand that the world is becoming ever so more based on data. Everybody wants to do data-driven development. Everybody wants to have as much data as they can on their website. Everybody wants to improve their game and log as many touch points as possible. But not everybody can write the code to manipulate and process the data. So that's where data prep comes in. It's a it's a smart tool for visualization and preparation of data. What I mean by smart, so by smart I mean that it has some machine learning baked into it. It automatically identifies schemas and then it has some recommendations when you're actually trying to run the process. And it's a very powerful tool for visualization because actually the next slide will show it is, okay, it's 2 slides ahead. So maybe here you can see, but you're actually able to look at the whole database and we have some visual representation. You can see that above every column you have a histogram of how the data is divided. You will
Sample.
Sorry?
Of a sample of the
Yeah,
data.
how it's divided. If you have, let's say, null values or out of scope values, then they will be marked in red. You will then be able to visually create this recipe, and you can see step by step what happens. You can do a split of one column into 4. It will happen immediately on the sample that you're currently looking on. And once you kind of take this recipe and click execute, it will actually happen on the whole data and you'll get the new table or whatever you didn't do. And the nice thing about data prep is that you don't have to be an engineer, you don't have to know how to write the code behind it. You decide what you do, you write the recipe, you see everything visually, you see how it happens. It greatly increases the time to preparation, or however you wouldn't call it. And we make sure that in the background it runs in Dataflow. So you can kind of achieve the same similar results without actually having to code. Questions before we go on to the third and last, and hopefully make it within the allocated time? Great. So the last one is probably the most favorite or the most interesting. It's once you've gotten the data, once you pre-processed it, once you've already stored only the data that you care about, only the data that is most relevant. The last stage is getting insights. Okay, maybe not the last stage. Once you actually have insights, you have to act upon those insights or nothing wouldn't matter. But assuming that you're able to act and execute your insights, this is the most interesting stage. I'm not going to go too much into Bigtable, just going to skim over it due to time. Bigtable is our infinitely scalable NoSQL database, which has one single key. The benefits is that it's a fully managed white column database which can scale to petabytes. It has one key and the access is millisecond access, which goes back again to picking the right product for what you're trying to build. If you want millisecond access and you want a NoSQL database, this is a solution for you. If you don't care about the access time and you're going to store key value pairs, then this is not the solution. And it's a very important point to stress because sometimes we've seen clients get really excited about a product and want to go use it, but then it doesn't fit their use case. And it supports the HBase API and allows you to interact via that API. You have to think about, well, I mean, I know that some people on my team are probably going to say that's true for every database. You have to design the schema and you have to think about how you're going to access the data before you actually save it, because you can only have one index key, and you would probably need to think about how you save your data, maybe save it in a different way if you would like to query based on a different key. And well, this is another differentiator that we have, where you can have like column families, and then you can retrieve based on column families. So column families, something from HBase, we support up to 100, and it just means that if you have certain types of fields which fit together, then you would probably want to save them as a column family, and we support a very large number, so you won't get capped. It also learns your access pattern, so it has this caching mechanism for certain queries, and it learns which you access more frequently, and it adapts accordingly. So here you can see that all the users are like trying to access the same data, and it's all going to the same worker. So we identify it and we switch it, which optimizes over time. It rebalances and makes it more efficient. And last but not least, one before the last one, and we're so far in time, is Bigquery. So Bigquery is our ad hoc query engine, and it's really great when you want to reduce your time to insights on very, very large scales of data. Again, it's fully managed, and works with the structured and unstructured data. It's an OLAP analytic engine, and you can scale it to petabytes of data, and you can also query it very fast. So it doesn't only scale to petabytes of data, but then later down the line, you can actually query those whole petabytes and get an answer very, very fast. Again, it does this concept which we're very much fond of differentiating, separating between compute and storage, where you pay for the storage and you pay for the compute, which means you can, again, store your data very efficiently, but if you query it, you pay for that separately. And you only pay for what you query. It's a pay-as-you-go system. It's fully SQL compliant, which is great, and really makes adoption easy. Thinking what else I wanted to say. The type of files which you can upload are CSV, JSON, new line delimited, and Avro format. The only benefit that I can think to mention here is that if you're uploading a really large data set, you might want to do it in Avro format. It would be better for us and faster for you, since if it's Avro format, we can upload it in parallel, and it's really not all that complicated to convert to Avro format. And partition tables, so right now you can do partition tables. Default is partitioned by 1 day, and it helps when you're trying to query a certain specific time frame or data, and you don't want to query. If you want to store petabytes, but you only want to query a certain week, it makes it much more efficient and much more easier. And you can work both streaming and batch, which means you can, let's say, create a pipeline like we showed before, where you do the pre-processing and data flow, and you stream the events as they come in to Bigquery. It's near real time, which means anything that you insert via stream, you can query almost instantly. What else I want to say? Oh, and batch. And batch, you can put the files, let's say, in GCS. You can upload them periodically into Bigquery. But a nifty, gritty thing is that we can also do federated queries, which means you can store it in a big table, and if you have a specific use case, you can use Bigquery in order to do a federated query over a big table, or you can store your data in GCS and do a federated query to storage. And last but not least, and it's not really going in depth, I'm not just going to touch upon it briefly. Visualization is sometimes very powerful if you're trying to get across a point, whether it's to colleagues, whether it's to a different department within your work, or whether it's something you're showing to executives, or just trying to, I know, a lot of time in my previous work we did it for internal motivation. We wanted to just, not only be aware of the insights, but be constantly seeing how they're changing over time. So we have Data Studio, which very easily allows you to connect with not only all of our internal database services, but you can connect them to virtually anything. We've just recently announced that we have community connectors, which will virtually enable you to connect any data source out there on the internet. And the great thing is that it's free. And that's me. Thank you very much. Unless there's any questions.
Share this on Twitter?
Yeah, I think I can. I'll go over it and I'll review whatever I can share. I'll share.
Thank you very much, Jonathan, and thank you guys.
Great.
Good night.